Hello fellow developers, I'm back again with an update to my HGDial library for the Android platform. This library is actually an open source library which is actually a dial control for Android, dial widget. For the purposes of this demonstration, I've used a dial as a menu system for this app. So I'm going to dial to the right to show you the main demonstration, which is here. As you see, there's a little dial there to put your finger down and rotate. I'll explain what those numbers do in a minute. But as a summary, this library tracks the rotation direction of the gesture, and it keeps count of how many rotations you've made, and a few other things as well. So you can tap the dial and you bring up these settings here, and these little flags here are actually the behavioral flags to adjust the way the actual library behaves. So you've got precision rotation, which corresponds to this number down here. That causes the rotation of the dial to happen at a different rate to the actual physical gesture. So with that setting there, with 0.5, if I put my finger down now, the gesture will actually or the dial will actually rotate at half the rate of the gesture, and that will actually keep count of the times I've actually rotated the gesture, how many times the physical dial rotates. That can be a negative number as well, so go minus 0.836 for example. That will rotate in the opposite direction. As you can see, it's still tracking the direction of the gesture and the direction of the dial. So you can see the object rotation is 1 because the dial is rotating to the right, and the gesture is -1 because my gesture is rotating counterclockwise. As I reverse, those numbers will reverse. As you can see, the gesture rotation count and the object rotation count are changing, and it's actually keeping track of everything nice and perfectly. So that's that behavior. Take the precision off, and that will go back to 1 rotation per circular gesture. You can see there. Okay, you have angle snap with angle snap proximity. That flag corresponds to these numbers down here. Now those numbers probably don't mean anything to you, but this library calculates angles in ratios of 0 to 1 rather than degrees. So 0.125 represents 45 degrees, and that represents 1/4 of that. This number here corresponds to the proximity, which I'll explain in a minute. So with that setting there, as you can see, that's snapping every 45 degrees, and still keeping track of the rotation count and direction on all those things. Proximity causes the angle snap to have free rotation between snaps. So what here, when you watch closely, it's rotating free between snaps. And we'll turn that off, it snaps directly into position with no free rotation between snaps. Now basically, this number down here with the proximity, we'll turn that off for the time being. Basically that's 1/4 of this number here, so that causes it to rotate freely for 22.5 degrees between snaps. When this number goes up to half that number or more, then there are no free rotations between snaps. So that said, we'll now go to min-max constraint. See, first I'll show you cumulative dial. Now cumulative dial, which is what I've shown you at the moment, when I put my finger down, the dial does not move until I move my finger. Non-cumulative dial, the dial rotates directly to where my finger goes down as soon as my finger goes down and rotates from there. Now, incidentally, the gesture rotation count and object rotation count don't actually work properly with non-cumulative mode, so it's keeping track there. If I put my finger back down, it'll go back to 0. But that's not really possible to fix because of the nature of what it actually does. So back to cumulative and it keeps count properly, as you can see there. Okay, so we'll leave it in cumulative dial. Single finger, which is what you've been looking at, put in dual finger. That does what it says. Just put your finger down, doesn't move, 2 fingers down, it moves. Now this actually rotating, it looks like it's rotating relative to 2 fingers. It's actually rotating relative to the second finger down. To demonstrate that, put my finger down, keep it still, and I can rotate it with the other finger as long as the other finger is down. I release the other finger, it stops rotating. Now the reason I've chosen to do that is because one of the constraints of developing this library is to keep it very processor efficient and responsive. So obviously it takes less of a processor overhead to track 1 finger than it does 2. So that was the reason behind that strategy. Back in single finger mode, and there you go, single finger. Min-max constraint, that corresponds to these numbers here. That's kind of almost what that does. It constrains how many rotations you make. So we'll go put that to minus 2.8834 and put it to plus 2.92 for example. And that will actually constrain how many times it rotates. So we'll quickly rotate. You'll get up to those boundaries, it'll stop rotating, even though my finger's still rotating. Detect when I reverse my finger, it starts rotating the other way, and it will keep up both bounds. So pretty straightforward there. Incidentally, literally all of these behaviors work together in perfect harmony, but I'm not going to bore you by showing you every combination, but they have been thoroughly tested. Like for example, if I put angle snap on while the rotation constraint is on, obviously it will still work and still snap, for example. So we'll take that off. Enable variable dial. Okay, that causes the precision to change relative to how close you're rotating to the center of the dial. So this flag, enable variable dial, that flag there corresponds to these numbers here in a precision. So with that flag set, what will happen now is the dial will detect how close I'm rotating to the center of the dial. So when I'm rotating close to the center of the dial, it will rotate 4.5 times for every circle gesture I make, and as I slide to the outside, it will slow down to that number there. So I'm going to demonstrate that. Make sure that flag is on, which it is. So put my finger down. As you see, it's rotating slowly. As I move my finger towards the center, it speeds up and then slows down again when I come back to the outside. Okay, and you can actually do some weird things with these numbers, which is quite strange. So, for example, if I go, so you end up being a negative number, and go -2 and say +2, that'll do something quite strange. So it'll rotate that way to the outside. As I move close to the center, it'll stop and slowly reverse, which is a kind of a weird thing. But so anyway, put that back to, for the time being, I'll put that back to 10 and 0. And so as you can see, that's back to slow to the outside and 10 to the inside. Okay, so again, all these behaviors work together. I put min-max constraint with that flag on, and as you see, it still clips the boundaries. Take that back off. Okay, so what we do now, I'll show you the variable dial curve and positive curve. Now, these are actually new behaviors. The fling behavior is also a new behavior, which is the reason why I'm republishing this video. Variable dial curve basically causes the variable dial to, basically the acceleration and deceleration of the rate of the dial actually happens on the curve. So to demonstrate that, you need to give a higher number. So for example, if I go 180, we'll leave it in ordinary variable dial. As you can see, as I rotate to the outside, it's very hard to make the dial rotate at a very slow rate. Now if I put variable dial curve on and touch the outside, I can actually rotate it extremely slowly, as you can see there, because the acceleration and deceleration actually happens on a curve. Which is, so this is actually a handy behavior that I added just in case you want to use a high inner precision but still need accuracy. Positive curve, that just means that changes the curve algorithm. So with that off, it actually accelerates to the outside. With that on, it decelerates to the outside. So it decelerates to the outside. It's a bit harder to control the number to the outside because it's decelerated. So that's just a little thing there. So also, we've got fling. This is a new behavior which I've actually added. What basically you can fling, with that set, you can actually fling the dial and it will go into a mad spin. So that actually corresponds to these numbers down here. So let's quickly take our variable dial off. Okay, so basically these numbers here, these are the fling tolerance. That means with that setting there, that means I have to move my finger 200 pixels or more and release it in 250 milliseconds or less for a fling to be triggered. And once a fling is triggered, it corresponds to these numbers here. Basically, start speed and end speed of the fling animation and the duration of the animation. So with those settings there, that means that the fling will actually start rotating at 10 spins per second and slowly slow down to 0 over the period of 5 seconds or 500 milliseconds. So I'll demonstrate that. Let's make sure that flag's on, which it is. So I'm going to fling there, and there you go. That rotates at a rate of 10, and it will slowly slow down and stop. And you don't have to wait for it to stop. You can put your finger down and catch it like that. Okay. So with these numbers here, if for some strange reason, I don't know, you want to make it start at 0 and speed up with the fling, you can do that. If for some strange reason you want to do that, so it will start slow and it will speed up. And it will stop after 5 seconds. You see there, rotate the other way. These flings can also work with negative numbers as well. It's all kind of quite intuitive. Okay, let's go back to here. Now, that shows you the fling. Also, another cool thing with a fling, if I go down to these numbers here, if you set both of these numbers to 0, it will actually fling relative to the speed of the physical fling itself. So if I go put that on variable dial curve for a second, what I'll do now, I'll fling it here. As you see, that's flung quite slowly, and it will stop after 5 seconds. Again, you can capture it before it stops. You can fling it again while it's still flinging. So that'll stop. Now, if I fling it fast, it rotates faster. So if I can get a nice fast speed on this. Okay, let's go to variable dial curves on. Actually, what's the inner precision? 180. Right, so should be able to rotate this quite fast. See there, rotate slowly. Okay, variable dial wasn't on, that was why. Okay, so we'll rotate it fast. As you see, that's a really mad fast spin there. That looked like it reversed, but it didn't. That's because it's just rotating so fast you can't see, and then again rotate to the outside and it's slow. So that demonstrates all of these behaviours. So literally all of these behaviours work together, but again, not going to bore you with all the combinations. I'll quickly show you how another cool feature of this library is how one dial can actually act on another dial. So I'll go back to the menu, rotate to the left, and I'll show you the overlay effect. So rotate that. As you can see, it's rotating another dial in the background there to make a really nice, cool, nifty 3D effect. And also, I've got a cog demo here, which it demonstrates the same thing, one dial acting on another dial. Now, this particular fragment I'm showing you doesn't just demonstrate the same feature, one dial acting on another dial, but it actually shows how the library can have live touch events pass from literally any view into the library itself. So you have a look at the code, you'll understand how that is slightly different to the other demonstration. So I'm going to close up this video now. When I publish this video to YouTube, I'll be putting the open source repository links. At my open source repository, I've got a few other libraries there. I've got an OpenGL version of this library, which exhibits exactly the same behaviours, except you can rotate. It has an extra feature where you can rotate distorted dials. And the way one dial acts on another dial is a bit more intuitive, and the way it deals with alpha blending is a bit cooler. That other library is a bit harder to use, but does more things. This one's more intuitive, easier to use. So that basically concludes what this does. I've recently added a donate button, open source donate button to this library, so if you guys are feeling generous, you can donate to the cause. This dial library now is coming up to a finish now because I've added every single behaviour that I can really conceive to a rotation control. So any updates for the future, unless I get some really bright ideas or someone else gives me a bright idea, I'll just be optimizing the code now. But the code is also very optimal, well documented. My other libraries, I've actually repurposed this dial code to make a thing called a fast list control. I've used a dial to actually move a list up and down. It's very handy. It uses the variable dial behavior so that you can actually move huge lists up and down extremely fast while still being able to zero in on the exact location in the list. I've also refactored this dial here to actually make a date picker. I've got a really cool date picker dialog and time picker dialog. The really cool thing about that dialog is that it does actually allow you to pick dates faster and more efficiently than the old time picker dialog, which is really cool. And the time picker, you can pick times phenomenally faster, so really cool there. This dial is also used in my AB playlist app on the Google Play Store. The dial is really cool. I use the variable dial behavior to fast forward and rewind videos, so you can actually because with the old video, anyway, if you watch the video, you'll see how cool that is. So that's about it, really. I will bid you developers a job. Thank you very much for watching my video. I'd appreciate any feedback. Would be greatly appreciated. I'll bid you a good day.